So this is the introductory activity for the Chatelier's principle that we've been working on in class the last few days about equilibrium. The first thing that you need to do for this introductory activity is to get these two beakers. The one on the left is some hot water on a hot plate, and the one on the right is some cold water with some ice in it. We'll need those later for part B, but you need to warm them up first. So we begin here really by getting 20 milliliters of 0.002 molar potassium thiocyanate solution and adding it into a petri dish of some sort. Like so. Note the initial color. This is another color change reaction like we've been working on lately. So you need to record the color changes as we go through this entire lab. Um, so here, I guess you could say step number 1, it's still clear. But yeah. Then what we need to do is we need to obtain some drops of 0.2 molar iron 3 nitrate. We'll be adding 3 drops to different places on the dish and recording the color changes that happen as we do that. So I've got the drops into the pipette, and I'll just try to add them here now. Give you a better angle from the side. So the first drop ended up being a little bit larger, but it'll be fine. So we'll add some other drops further to the back so that there are 3 different drops in 3 different places, like so. And then wait a little bit for the color changes to happen and noting the color changes. Once that's done, you need to swirl the solution like that so that it's all homogeneous all the way through, this darker shade of red than it was earlier. The next thing that we'll be doing is we'll be adding some more potassium thiocyanate. The lab calls it a half a p amount, so here it is, half a p of the crystallized potassium thiocyanate. And we'll be adding that again to the petri dish. Doesn't matter too much where you put it, so we're just putting it here into the dish, like so. Again, we'll get you a closer angle here, and we'll just zoom it up for about 30 seconds again. Just record the color changes as it happens. And you should see that darker red shade starting to like come all the way through. So adding more potassium thiocyanate in this step made the color change darker. Again, you just swirl it so that it's all homogeneous all the way through. Now it's an even darker shade of red, almost like I don't know, almost purpley. But now we do another half a p. This time we're using potassium nitrate. It's a much finer crystal, but we'll be adding another half p amount into our solution, just like we did with the potassium thiocyanate. So into the dish it goes, and a closer view for you to see if any color changes happen during the next this one is about a minute, the lab says, for this one. So just let it go for a minute. Again, I zoomed this up, so it's not a complete minute for you if you're watching this. There you go. This one, you can swirl it. You shouldn't see a whole lot of color change on this one. It's still that dark red like you can see here, even though we added the potassium nitrate. So in that step, not a whole lot happened to color. So we'll actually be moving on to the next step. The next step is a quarter of a p of sodium phosphate. So a smaller amount of the sodium phosphate, but we'll be throwing it on or into the solution. And again, recording the color change that happens. So here's a much closer look for you for the next 30 seconds. Sorry about the shaky camera work too. It's, I was just holding the camera. So you'll see here that inner circle where the crystals were added is turning much lighter, much lighter during this time interval. It'll be even more apparent now when we swirl it and the solution becomes clear. So adding the sodium phosphate in this step turned the solution back to being clear. Again, we're going to add another drop of this 0.2 molar iron 3 nitrate onto the petri dish. We saw earlier that when we added the iron 3 nitrate, it turned it darker red, turned it orangish. So we're not going to swirl this one yet because we'll add some potassium thiocyanate to this dish as well. So there you go. Again, record the color change after adding the one drop to one particular location this time around, like you can see here. This time you use a whole pea of this potassium thiocyanate crystals, add it to another part of the petri dish, like so, and record any color changes around the potassium thiocyanate this time around. Again, the potassium thiocyanate didn't do much, but when you swirl it, you'll see that the two mix and form this orangish shade, because we expect it to be dark red, but there was more potassium thiocyanate, so it turns a little bit clearer, if that sort of makes sense. But now we can use this solution that we've basically made for part B of the introductory activity, where we'll use these two test tubes. We need to put about equal amounts into each of these two test tubes. The one on the left we'll call test tube A, and the one on the right we will call test tube B. A will be our control test tube that will be comparing the results from B to once we add or submerge A, or once we submerge B into the hot and cold water baths. So yeah, there we go. B, you can note the initial color. Like I said, it was an orangish color. Actually, more orange than I expected. But this is test tube B, and we're putting it into that ice water bath. Very cold because we have added some ice pieces to it. And then we're going to wait 3 to 5 minutes for any color changes to happen. So here we go. 5 minutes later, we can take it out of the ice bath and compare it to test tube A. You'll see that the one on the right, test tube B, is way darker. That tells us that there are more products present now after adding or after taking away the heat. There are more products present. That should tell you one side of whether or not this is endo or exothermic, depending on which side the heat is on in the reaction. Which is kind of the point of this introductory activity, is to expose you to how temperature relates. And then just like we did with a hot water bath, we want to do with just like we did with a cold water bath, we want to do with a hot water bath. 70 degrees is what you want there. Mine was reading 71.2-ish. But you want to put the test tube into a test tube holder so you don't have to hold the test tube over the hot water for those 3 to 5 minutes. So like so. And now we wait again. 5 minutes later, here's what our test tube looks like. You don't want to pick this one up because hot glass looks just like cold glass. That's probably some pretty hot glass. So we bring test tube A over, and you'll see, hopefully, that the one on the right is way lighter, which tells us that there are more reactants present now that we've added heat to the reaction. Because the potassium thiocyanate is clear, and that is a reactant, as opposed to the complex ion of the iron thiocyanate ion, which is that dark red that we've seen earlier on. So hopefully that tells you a little bit about Le Chatelier's principle and how it really relates to heat in this reaction, whether or not adding heat or taking away heat shifts the equilibrium to the right towards the products or to the left towards the reactants. Um, Again, the color change is useful because the complex ion is that darker shade of red, whereas the reactants are more clear. So hopefully that gives you a little bit of indication for what's going on there. And then I guess we'll go into part B. Sorry, this one's a little bit long. There's just a lot of steps and a lot of things to add. So is what it is, but hopefully that helps.